Thank you all so much for being here as the last session of the day. I will probably be out right now with a pint, so I appreciate it. Welcome to this talk about Wasm. Wasm's components are a FaaS best friend. This is the agenda. I'm going to talk about function as a service. I'm going to try to give you my opinion on what makes a good function as a service runtime, different than an actual function as a service. And then we'll talk about a practical example, which is building a FaaS with WasmCloud. My name is Laurent Doguin. I work as Director of Developer Relations at Couchbase. Couchbase is the developer data platform for critical application in our AI world. That's the official messaging. It's just an incredible database. There you go. L Doguin on social. I have a brewery. It's called La Marmotte Masquée. It's in France, in the Alps. You should visit. It's pretty great. And if you want to see my writings, it's on that website down there. Might talk about Couchbase here and there, but like not really. So, what is a function as a service anyway? To me, a function as a service is all about running application functions, so function in a context, when needed on a serverless runtime. Now, usually what happens after this phrase is, now what is a serverless anyway? Which is a good question. To me, serverless means it's an execution model. It's how you run code without having to care about servers in the wide term, not just racking machine, which I used to do that when I worked for a cloud company, without managing servers. And the extremely important part about this is also allocating resources when you need them, meaning you don't pay for something that's not running and you don't use something when you don't need to, which is pretty cool when everybody's generating images with GPUs. So function as a service is different from serverless. I just want to put that out there because I have lots of people that are saying, well, it's the same thing. Function as a service is a subset of serverless. It's serverless, but running one very specific little bit of code that inscribes itself into a broader context. Now, if we talk about execution model, usually you get those 5, that's probably CAS in the middle that's missing because that slide was too small, CAS being container as a service. And so basically you have different layers that you have to think about, maybe manage, depending on what you want to do. The traditional use cases would be, traditional might be a strong word, what people used to do, and people might do again because of all the stuff that are going on, is on-premise. And on-premise, you have to buy your own hardware, you have to rack your own hardware, you have to take care about the network, you have to take care about your virtualization layer, KVM, QEMU, whatever. You have to manage your own operating system. And usually, there's the operating system that manages your virtualization layer, and then there's the operating system that runs on every of your VM. So all of those needs to be managed, updated, and all that stuff, which is quite a bit of work. And then you have the container layer on top of it. And guess what? The containers also has its own system. So you also need to think about this, manage this, update it, all the things. Then you have the actual runtime. So let's say the JVM, if you're doing Java, then you have the Java application. And then you have maybe functions. So if you're on-prem, you do everything. If you do infrastructure as a service, you go to your good old cloud provider, and maybe you use just EC2 on Amazon, or maybe you use other cloud that people have forgotten about, that were here before AWS, like OVH in France or Hetzner. Or, I mean, there's lots of local clouds in every country. And then you have container as a service or platform as a service. So instead of managing operating system or containers and runtime, now the only thing you have to care about is your code, in theory. Your code as an application and your code as a function. Then you have function as a service, or you use function, et cetera, et cetera. And then SaaS, which is like, whatever, I'm just going to get a subscription and not manage anything. So instead of having a very, very narrow and precise definition of function as a service or serverless, what I want to talk about and what I want to bring you to understand is it's more of a mindset shift. Instead of managing all those stuff, you try to manage only what brings business value, which has been what I've been saying to my customers when I was running a platform as a service. Just write your app. You don't care about the other stuff. And then sometimes it's not just about the apps, it's also about the function. So just care about what brings value to your business instead of infrastructure. So what makes well, not what makes a good function as a service. I'm ahead of myself. Advantages and disadvantages of function as a service. The great thing about having a FaaS or serverless runtime is you don't have to manage server in the broad sense. You don't have to manage your infrastructure, again, in the broad sense. I don't know if you are, you all have a software forge, if you use containers, do you rebuild your containers all the time just to make sure they're always updated? If you do you do all of that? If you do, that's great. I don't, and I don't want to, I don't even want to care about this because that's a waste of time for me. It might not be a waste of time for other people because, you know, what could be business for me could be infrastructure for you. Coming from the database space, most of our customers, we do a lot of cache. They implement their own user session store. Most people don't need their own user session store. They use Okta or whatever, Keycloak, anything, and then just use that. So here you are basically serverless. You're not, it doesn't bring any business value, so you just use an off-the-shelf solution. For some of our customers, we had SkyTV. For SkyTV, it was very important to build their own user management system because when everybody logged in at the same time to watch Game of Thrones, at the exact same time, you had to check the rights and the permission of every single customer of SkyTV. And so the usual off-the-shelf user management service that they use blown up. So what brings business value to you might actually be an infrastructure and something that people have to build on their own. But anyway, don't want to care about this. I don't want to care about orchestration. Don't want to care about scaling up and scaling down, especially if you're managing small bits of code that have a very short life duration. If you manage a server, like, okay, it doesn't need to scale up and down so often. But if you want a pay-as-you-go model, and you don't want to manage the up and down of your function all the time, that sounds like a lot of work. So you want something that does it for you. And of course, if it does it for you, you want it to be, you know, highly available. Things in the cloud fails all the time. Well, all the time might be a strong word, but it happens, right? And if it happens, you need to be ready. So you need to have a distributed architecture so that if this node goes down, well, there's still some other nodes, some other hosts that can deploy those functions. Event-driven support is an interesting one. What most people think about event-driven is, for instance, Kafka or any messaging system. You know, there's a message that shows up and then you deal with it. But it's also an HTTP call. You can think of an HTTP call as an event happening on your system, and I'm spending too much time on that slide, obviously. And then you need to react to that event. You need to do something. So basically, you have, I don't know, Nginx, any proxy. There's a call that happens, and then you need to start a function, execute that function, and then do your thing. Most people want to do polyglot. Most people, as in big companies, and you have people that do Java, some people do JavaScript, some people do C#. The great thing about a function as a service is that usually you can run any kind of code, which makes this very cool and very polyglot. It's still, basically they all talk together through a messaging system most of the time. So you get one function that goes up, gets the result, send it back to another message stream, and then you get another function that picks it up and do something. Or maybe it's just writing something on S3, and when something is written on S3 or something happened on that bucket, then you can execute another function with another language. And something that most people put forward doesn't necessarily mean it's absolutely needed to do a good function as a service, is a rapid way of developing a rapid cycle of deployment, which makes sense. Like, it's supposed to be a small subset of code, so you shouldn't have as much constraint when you're shipping a smaller code than smaller bits of code than an actual big application or Monoliths or whatever. Now, one of the problems you could have with FaaS is call starts. When that HTTP function comes in, usually there's a user at the other end, and users don't want to wait. So if you have to start a new function, which is basically start whatever you're using to execute that function, could be a simple process, a VM, a container, whatever, I'm going to talk more about this, then you want this to happen as fast as possible. So cold starts are important. It's hard to run very, very long function in most existing function as service runtime for a variety of reasons, but mostly when when you're building a FaaS and you're selling a FaaS, the idea is to resell the same hardware as much time as possible so that it doesn't cost you too much money. So you try to have a timeout to reduce the duration of the execution of the function because, well, that's how you make money, right? All depending on how you cut your hardware. Are you using VM? VM are heavy. If you're just using a process, you can probably have many processes running instead of many VMs. But then, is it a good idea? We'll talk about it later. Now, stateless is an interesting one. It might be seen as a problem or as a good thing. To me, stateless is always a good thing because I come from writing code, not operating software. And so stateless means it can scale indefinitely because I can just start a new actor and then I can start as many actors, many components, many functions as I want. It doesn't matter. There's no state. It's not going to talk to a database or anything. So on one end, it's great. On the other end, well, someone has to take care of all the other stuff, like the database, the S3 bucket, the messaging system, all those things. So you have to integrate into all those things. So usually that ends up being a very distributed system. And we all know that distributed system, well, first of all, the more you distribute it, the higher is your failure rate for a variety of reasons. But basically, the more hardware you have, the more chances you have to do that so that hardware fails. And then vendor lock-in, there's lots of open source solutions, but basically, the way you write function for this solution might be different than for this solution, which kind of suck. It's hard to operate, it's hard to orchestrate, all of that. So, from my perspective, a great FaaS platform will give you the following. A very short cold start. It's polyglot, mostly because everybody wants to, you don't have to, but like, come on, it's 2025. Integrate with all your existing systems. I talked a lot about database, about stateful stuff, key value or S3. The other big part about integrating with other systems is security, which people tend to forget. But like, you can't just run code on its own somewhere. There's always, guardrail security stuff like this all around, especially now that people are building agents, and agents tend to do what they want to do. So you want to have as much guardrails as you want. So it's absolutely important to be integrated with your security systems. I want something that automatically scales up and down, scale to 0. If I'm not using it, I shouldn't pay for it. That is, secured, observable, always on, all that stuff. So what makes a good FaaS runtime? The runtime being the thing that your function as a service is running on. The early choices that we had when thinking about function as a service, I don't know when, as an industry, we started thinking about function as a service. My guess would be, there was the cloud, the commoditization of hardware. It became much cheaper. So if it's cheaper and very well orchestrated, we all have APIs to start new things the way we want to, then maybe we can start thinking about, scaling up and down when we need it and all that stuff. And so at the time, three main ways to execute processes. The good old virtualization layer, which is super isolated because it uses all the fantastic instruction that the CPU gives you, which is like VTX or AMD V something. Basically, the hardware thing that makes it that your VM are completely isolated from other VMs. It's great. It's also very slow. It's not that slow, to be fair. When I used to work at Clever Cloud, Platform as a Service, we used VM all the time. We didn't want to use container, more on that later. And if you remove all the unnecessary thing from your VM, it starts in a matter of seconds. And at the time, we were thinking, oh my God, it's VirtualBox. It's going to be so slow, or it's going to be VMware. It's going to be, no, KVM, actually, pretty good. Starts very fast. And then you have to manage the OS that runs the VM, and then the OS of all the VM, and all that stuff. Then you have containers. So containers, LXC, Linux namespace, everybody's sharing a kernel. It starts much faster than a VM, but then you still have to manage the OS of the container and everything that's on it. But also, it's not as isolated as a VM, which is a terrible idea when you run code that you don't know. I'm not going to have a machine and run your code, and if you don't know each other, there's probably a good chance that you're going to tell me you should not do that, and you'd be right, depending on your paranoia level. The good thing is, most of those VM and containers are pretty easy to move around. You have something that knows how to run VM. You can run this everywhere, same for containers. So it's pretty portable. The overhead of a container is super low. That's why it's faster. You're just using the same kernel, and using the same kernel, you're segmenting things. Whereas with a VM, you emulate the whole hardware, and you do all that layer, so it's not as lightweight, so big overhead. And then you get native process, which is a terrible idea, because you have zero isolation. You have a system, someone has to run a process, you just run a process, and really, why would you do that? And actually, no one's building any solution, I think, on top of that. So what does it have to do with George Costanza? It's a security problem.
What are you doing? What? Did you just double dip that chip?
Excuse me?
You double dipped the chip.
Double dipped? What are you talking about?
You dipped the chip, you took a bite, and you dipped again.
So?
That's like putting your whole mouth right in the dip. Look, from now on, when you take a chip, just take one dip and end it.
Well, I'm sorry, Timmy, but I don't dip that way.
Oh, you don't, huh?
No. You dip the way you want to dip. I'll dip the way I want to dip.
Give me the chip!
Hey!
So all of that to tell you that if you think about the dip as a Linux kernel, and if you think about the chip as a container, which is exactly what it is, then that's what happened. And all of that is to say that basically security is all about the acceptable paranoia level you can have when executing code of other people. And that's the moment where you're all angry because I ask you if you have trust and confidence into the code that your colleagues ship, and would you trust the code that your colleague has shipped to run it on the same, his function on the same runtime than your function? What if that function just, kills the kernel that's running down there? Then nothing works anymore. So how paranoid do you want to be? Do you want to be the CIO like George who doesn't care, or do you want to be like Timmy and try to isolate stuff? Turns out most people want to be like Timmy in tech, which is a good thing. There's newer choices than just VMs and containers and straight-up processes. The first one that got really popular, mostly because of AWS Lambda, was micro-virtualization, when they created this thing called Firecracker. And so what Firecracker is basically a micro-VM, so a VM that starts much faster than a traditional VM, more lightweight, still give you full isolation with all the cool CPU instruction that you get from VTX and MDV. Extremely portable, it's just a VM, whatever. The overhead is not as big as a traditional VM, still bigger than a container. But you still get that super isolation. This is what AWS Lambda uses, and I'm sure there's other people using Firecracker. Now, the other thing, containers. Containers is what you just saw before. It's the dip. It's when you have two things sharing the same kernel, and this container basically segfault the kernel. Anything that was running on the same kernel, gone. To avoid this kind of stuff, you can do hardened containerization, and there's a couple of solutions that exist. There's gvisor that's used by Google on their, I forgot the name of their offering, but basically on their FaaS. You get Kata containers that's maintained by mostly Intel and a bunch of other people. And so the way it works is trying to provide a stronger level of isolation than just C groups and namespace that you have on Linux. So it's still as good as a container, and it's better in terms of security. It's hardened. And then you get WebAssembly, which is probably the reason why everybody's here. So it's like a process, but it's not a native process. It's completely isolated. I don't know why I have the VTX here, that's a mistake, but whatever. The security premises of a Wasm module is basically, here's a buffer of memory, and whatever happens, you won't be able to get away from that buffer, to get out of that memory buffer. And by default, it has the right to do nothing. It's like OpenBSD or FreeBSD. You know, it's completely closed by default, and then you can enable the feature that you want based on the Wasm runtime that you use. It is oh so much faster because it's just a process. It's fully isolated because, again, it's just one chunk of memory instead of a whole OS, and you don't have to care about the OS and the runtime and the app, which is also something that I should have removed from that slide. But anyway, WebAssembly is amazing. And if you take a score on all the things that I've just showed you and you ask ChatGPT to do something, then that's what goes out, which is a little cheeky, but basically, Wasm scored the highest in terms of portability and security and everything. So the question usually is, why are we not using Wasm everywhere? And there's a very good reason for that, and that's this. So if you want to move a string from a Wasm module to another, or for a Wasm module to a host, or from the thing that's executing the Wasm function, well, that's what you have to do. You have to, basically, you only have integer and float, and so basically pointers and numbers. So what you have to do is pointer and numbers. Basically, you get the slice of the buffer that you're interested in, and hopefully, the way it's encoded in that memory buffer is the way you will decode a string. But this changes based on the language that you're using. So it's kind of a mess, really, if you want to do more than a hello world. That's just for a string. Can you imagine what that would be if it was a JSON document, for instance, a JSON string? It would probably be the same thing, actually. But if it's different structure, different objects. So this is where things get interesting. This is new. This is called the WebAssembly Component Model, and this is an official specification created by the Bytecode Alliance, which is a bunch of people that basically standardize the way we're supposed to use WebAssembly. What it is a set of things. It's first of all the WebAssembly interface type, which is a way to describe types and function signature. You can leave it at that. And then you have an ABI, application binary interface, that knows how to manage string list, structure, basically all the basic type that you can describe with your width. And then it also allows you to define how you link different Wasm components together. And also, that's the big part, you don't have to manage memory anymore, which is great because I don't want to. So that's the exact same thing that I showed you earlier, but with the Wasm component model. Instead of doing this, to parse a string, and the Rust version is actually much easier to read than the JavaScript or the Go version. All you have to do is this. You create a namespace, it's called myfunc. You get your function definition. It's called process, it's a function, and there's one parameter, it's called message, and it's a string. And what it's going to do, you get the tooling that's going to generate the binding automatically, so that each time you use this, you import or export this into your with compatible language or project SDK, then you can just do this instead of this. So basically, everybody in the Wasm world is ecstatic about this and has high hopes that this is going to allow for a much broader adoption of WebAssembly outside the browser. So to do a function as a service, for instance. Basically, the whole goal of this is to increase portability between Wasm modules, Wasm components, and across languages as well. Because again, the way you encode or decode a string might be different depending on the language, but with this it doesn't matter anymore. So it's super easy to go polyglot with something like this. And it's also super easy to have those modules talk to each other instead of just playing with byte buffer and stuff. I'm awfully slow, everything's fine. So practical example with CNCF wasmCloud. One of the reasons I'm here today working at Couchbase is because one of our dear customer, American Express, and a company called Cosmonic, which is the main vendor behind wasmCloud, came to us and said, American Express is replatforming its own internal FaaS onto wasmCloud. And they use Couchbase everywhere, so they need Couchbase support, so that's why they came to us. And so I'm going to tell you how it works and what you can do with it, and what we had to do to make that work. So I'm going to tell you everything, well, maybe not everything, about wasmCloud. So wasmCloud is a set of software that allow you to build and manage a polyglot Wasm application orchestrated across anywhere, really. I mean, it says across cloud, containers, Kubernetes data center, edge environments. It is extremely, has an extremely low overhead, and it just runs Wasm stuff, so it's very lightweight. And it's basically two things. Two CNCF official projects. wasmCloud, bottom left, NATS, bottom right. NATS is a messaging system, and wasmCloud is, what is this? It's a thing that allows you to, well, I've said that already, manage cross-platform polyglot application. The goal is to have just one predefined way of explaining what is a function or an application. If you can do an application, you can do a function. How do you, what's the manifest? How would you describe an application that's running in a serverless environment or a functional service environment? And how you make sure that it can scale easily, that it can do that safely, and all those things. Lots of different ways to run this. I already talked about this. That's the most important thing. Why would you even do something like this? The great thing about a functional service and what wasmCloud allows you to do also is you build component. Component can be like actors. It's the thing that will execute code. It's the stateless bit. If it's stateless, you can scale. It's reusable. It can run anywhere, and you can use any language because, well, it's Wasm. It's fully distributed. Observability in fully distributed system sucks, but you get full support of OpenTelemetry, so it's super easy to get your traces, your logs, your metrics, everything out of wasmCloud. Everything is, well, basically made for that. And they have one cool UI that allows you to see everything. I don't know if it's production appropriate. I think most people will build their own custom UI to do this, but it's there, and it's pretty cool. It can integrate with everything. You still have to write the code to do that, but it can integrate with everything. And of course, it runs anywhere. Now, what it is basically one software, the control plane, the thing that decides how to run your software, how to talk to each other through a local version of NATS, a messaging system. And that's NATS that's going to do all the clustering and all the messaging. And on top of that, you have actors and providers. I haven't talked about providers yet, but here we are. wasmCloud cluster is called the Lattice. And Lattice is made of several hosts. And on several hosts, all those hosts, you can run two things. You can run component, and you can run what we call capability providers. So here you see one event. There's an HTTP request that's coming in. The HTTP request is coming in to the HTTP provider. Once that happens, there's a message that goes through the capability provider to the messaging system, NATS. NATS sends it to the component that is linked to that HTTP provider, and it's probably going to manage that request. Apparently, that request needs to do a key value get into another provider called the key value provider, and this key value provider is going to go outside of the Lattice, and it's going to talk to whatever can implement a key value interface, Redis, Memcache, Couchbase, you name it. And then it's going to go back, and then it's going to answer. And you can have as many hosts as you want in the cluster. So, four main components. I shouldn't use the word components because it's already a thing. Four main things into a Lattice. You get as many hosts as you want, which is basically an instance of wasmCloud. An instance of wasmCloud will deploy components and providers. Components are the stateless bit. Providers are the stateful stuff. So, a provider doesn't have to be Wasm. It could be anything that can talk to what you want. So it's a process that also import and export and uses the Wasm component model so that it can also talk to the component through interface, which is basically the width definition thing I showed you earlier, how you define function, how you define types, how you define all those things. And everything goes inside a Lattice, which is a mesh of all those hosts that can deploy any component or providers, an interface or links between the two. The role of NATs in all of that is to be the messaging system, the way things talk to each other. They don't talk directly to each other, unless you're on the same node. They will go through NATs. NATs is a messaging system, so if you're familiar with Kafka, with Red Panda, with all those things, then that's pretty much what it is. You get the NAT server, and some clients connected to that NAT server. All those NAT servers will create topics, basically messaging bus that are tagged with a name. That you can send as many messages as you want on those, and those messages will be gathered by clients. And you can have any sort of clustering that you want. And that's the cool thing about NATs, and that's why I think it's an amazing product. It is super lightweight. It runs on, I don't want to say it runs on anything, actually I'm not sure, but it's extremely simple. You get, on the website, they say we are topology enabler, and I love that. You can have all sorts of network topologies with NATs. They have 2-3 different interesting concepts. Single server, you all know what it is, a cluster, so several servers together. You can do cluster of cluster, and then there's it's not in there, but basically you have a gateway node and another gateway node and a full cluster behind those two gateway nodes, and all the traffic goes through one or several gateways, so that you don't have each server to each server communication, because there would be a lot of network, but instead just basically proxy, they call that gateways, that allow you to do clusters of clusters. And you have this amazing field called a leaf node. The way cluster of clusters and gateway works is you have to have bidirectional communication, which in the cloud means egress, basically. And egress is expensive. With leaf nodes, you only need one-way communication. So when we did a workshop, last week? 2 weeks ago? Last week. 2 weeks ago, at Wasm.io. We had one cluster in the cloud, and then everybody was using GitHub Codespace. It's like a developer environment online. And they would start their own wasmCloud instance on their Codespace environment. And it's TCP, so I cannot expose anything outside of Codespace. But I can have a unidirectional connection between my Codespace and my cluster. So with NATs, I can create what is called a leaf node, and basically it allows you to do the same kind of thing, cluster of cluster, but instead of having the two-way direction, you have only one-way connection, because it all go through the NATS messaging system, and that allows you to do all sorts of cool stuff. Now, messaging is good. Messaging with persistence is better. So they have this thing called JetStream. JetStream is the persistence layer of NATS. It provides several things: persistence for your messages, key value, and object storage. Object store like this. Like literally what this thing is going to do is it's going to split whatever object you send it, and it's going to basically distribute it into several key value pairs, and it will allow you to store anything, like a movie. And then key value, which is a bit like Redis. Really, same sort of interface. How would you build something with wasmCloud? How do you basically split your existing things? For us, it's mostly a function, but it could be an application, into components and providers and all that. What I like about what Cosmonic is building, the people behind wasmCloud, is they try to have capability standards. On the first slide you saw, there was an HTTP server capability provider and a key value capability provider. HTTP server is just an HTTP server, it's just like whatever, it's a server. The key value one is just something that can do, get and read and touch and what you expect from a key value. So it's not tied to a particular data store. It's just a generic capability, so a generic contract. So if you think in terms of width, the definition of your function, there's going to be a function that's called get, there's going to be a function that's called read, there's going to be, it's going to be the same. But the implementation can be different. So you can have different capability provider that have the same key value width definition, the same capabilities. So that means that if your Wasm component uses the key value interface, then you can interchange whatever capability provider you have that also can export the key value interface. So you can switch from Redis to Memcache to whatever. And that's the case for key value. That's also the case for messaging. That's also the case for SQL, anything you can think of. This is the basic way of seeing things. If you're in a big companies, I'm assuming you don't usually use your data store straight up. Usually there's some sorts of middleware that go and sit down in the middle to, I don't know, manage security and a bunch of other things. So you could very well also have capability providers that maps all your middleware and then makes it available to all the developers in your organization for just writing one bit of code, which is super powerful because then you can build your own platform with your own stuff without having to rely on the crazy architecture that you can see in other clouds that makes you use all that generic stuff. So one way of seeing this could be, what is my application or function going to do? Identify all those capabilities, then choose the capability provider depending on your platform, depending on where you're running it. There's labeled support in Wasm host, so you can put a label on a host and say, well, this host is labeled EC2, and it's going to basically only be deployed in the hosts that have the label EC2, or whatever else label you can think of. So you can basically choose where the component and provider are going to go, based on what you have available. And once you have identified your capability provider, then all you need to do is deploy your wasmCloud application. So let's say you have an incoming request that shows up. There's a component that's going to get that request. Most likely, the first thing is going to be an authentication component, an authorization component, and then it's going to either send it back or go through the next component. And the next component can do a whole bunch of things. It can talk directly to a capability provider, or it can also go through the inventory management component, which itself can, talk to a capability provider or another component, etc., etc. If you're familiar with AWS Lambda, this should feel familiar. And of course, but I've talked about this already, lots of different capabilities are available: HTTP, key value, messaging, blob storage, really anything you can think of. This is an attempt to have generic contracts so that you can easily replace capability providers through whatever is available on your cloud, which makes it a great solution to do multi-cloud, cloud to cloud. But really, capability can be anything you want. They have a great tool called Wash, which is basically, you can't go install Wash or whatever. It's pretty easy to install, and all it does is download NATS, download wasmCloud, download Wasm, which is the thing they use to define applications. Sorry, how much time do you have? It's 50? You can do all that stuff. Basically, think of wasmCloud as Kubernetes, but for WebAssembly instead of containers. And I'm going to try to show you how it works in the time that I have left. Opening Gitpod, which takes a little bit of time. And so my goal will be to show you how easy it is to deploy something, and also to show you the deployment model, the specification that they go after. If you're familiar with Kubernetes, it should feel extremely familiar to you once it's available at some point in the near future, very soon, or on GitHub. This is my colleague Ben. We did this workshop together. And so you can go on that repo, and it's going to send you, there's a README to do the workshop. So if you want to do it by yourself, you can. And that's the bit I really wanted to show you, which is absolutely awful in a dark mode, but that's all right. Are you up? Not up, whatever. So this is the manifest that you have to write to express what your deployment will be. An application will be a set of components and capability provider all linked together through what they call links. And so you can see basically a name, a description. Again, if you know Kubernetes, that should be fairly familiar. So I have a component, that's the stateless thing. That's my Wasm file that I've built. Here it's on the file system, but of course you can go to any OCI compatible repository. And it has a trait, and this trait is basically a built-in capability. The trait is a spread scatter. So basically it's going to say I'm going to deploy one component, and only one component, with only one instance. But if I have 100 instead of one here, it would have deployed 1 to 100 components, depending on the needs. But also the important thing is the next one, which is the capability provider. That's the image instead of the file, so it's going to go to an OCI registry, is going to get it, and then we're defining a link. And the link is basically saying, this component is linked to this capability provider, and what this capability provider does is it's an incoming handler. If there's anything that shows up into that IP address, then I'm going to take it, and I'm going to send it to that component. They have, I think they have two different traits right now. They have spread scalar, which is the auto-scalable one to whatever, and then they have a daemon scalar, which is making sure that you have one of each running on each host that are available on your cluster. Well, something went wrong, and I think it's time for questions, so I can probably take questions, and if not, I can probably try again and see. Do I have any questions? You have no questions? You can watch this for hours. It's probably going to fail again, because there's no reason why anyone sane would just hit reload. Like, that's not how things work. Maybe. Maybe not. If you don't have any questions, let me show you a bit of the hello world code. So that was the manifest of my application, defining a component and a capability provider. That's the name of my component. When I'm going to build it, the tool washbuild, which is a wasmCloud tool, has a target. So I'm targeting WASI Preview 2, which is the runtime that runs my Wasm component. The language is Rust, it's a component, blah, blah, blah. There's a with definition, which is my contract. It's an actor. It has a request, payload. It's exporting. It's using the incoming alert export, which is basically getting the data from the query. And if I go to my code, it's fairly simple. I'm importing. I'm not importing, I'm importing. Oh, yeah, there it is. The HTTP provider. I'm using the, I have the request, and what it's doing is basically taking the request and sending back, hello, wasmCloud, which is what I wanted to show you here, which might happen. Because, of course, if you do the exact same thing, sometimes it works, because why not? All right, so. Well, that was fun. Point is, if you go to here and scan this, it's going to take you to the exact same thing. There's a link to open this in CodeSpace. There's a link to open this in Gitpod, whatever is your favorite online IDE. The good thing about this online IDE, it comes with everything pre-set up, everything's installed, you can just start using it. You can also clone this and install this yourself. But basically, you can be hands-on and not rely on Gitpod like I did, which was a terrible idea, apparently, for once. First time it happens. And thank you. And if you have any questions, I'll be happy to answer. And if you don't, I have a train to catch. Yes.
Hi. Yeah, so I'm new to this, so maybe it's a stupid question, but how well does this scale when complexity goes up? I mean, obviously, it's like small functions. So
Yeah.
like maybe some real-world-ish use case that you can share?
I agree. That's the main issue well, basically, if you think about function, basically it's microservices but smaller. If you think about microservices, there are so much issues that comes with distributing, your services, whether it's orchestration, observability, making sure everything works together, increasing the rates of failure, increasing reliance on network. A network is the less stable thing in the world. So basically, you're doing this, but worst. Yes, it will rise in complexity, that's for sure. The good thing about wasmCloud is that because you can have your own capability provider and your own middleware, you can sort of get away with it, which is, again, strong quotes on that. It's probably easier to reason in terms of middleware and a bunch of capabilities that you can expose directly than to basically be hooked to, I'm thinking about lambdas, and if you start scaling your lambda architecture and you start using all the services, it's hard. Hopefully you can hide that complexity by using this. But there's no shortcut. Like the moment you start decoupling, you'll have problems. Some class of problems. There's no magic. I come from a platform as a service background, when the time where people would just deploy Rails in production through Heroku or Clever Cloud. It still works, Maybe we don't have to do all that stuff. But if you do, and let's face it, American Express is a big enough company, so they kind of need that, and most cache-based customers are on the same side of things, then it's easier, and it's better. Thank you. We have one there, and we have one there.
I'm not that new to Wasm. I've been using Wasm for front end, but the back end side is new for me. I've been touching bits of it, but there is a tendency to shift the cloud architecture towards the FaaS. And how far is it away still that the containerization is being shifted to FaaS? Because I see as well that's a big opportunity.
Everything's a cycle, so it's always like cycling, I guess. I know people are going back to Monoliths as well. People are distributing more and more software, and that's one way of doing it. Is this a good idea? Is this where everybody's gonna go? I'm not sure. Depends. If you look at AI agents and MCP server, basically that's a playbook for that kind of stuff. People will want to have as much as a service, as much auto-scalable from zero to whatever, small bits of code that can only answer one specific problem. So in that case, it probably makes sense and people will go all in on this. And at the same time, as these use cases are more common, then you get the actual runtime to run that. If you would have tried to do this with just VM 15 years ago, that would have been a terrible idea. But now we have Hardened containers, and now we have Wasm, so it sort of enables people to do it. And we're tech, like if we're unable to do something, there's a good chance we'll do it anyway because it's fun. And that's what we do. Does that answer your question?
Yeah, it does. I'm just thinking further that FaaS itself helps us solve the green software problem as well, because you're running using the CPU that you need.
I don't think everybody needs that, but I think in terms of CPU, in terms of being green, it's great because you only use what you need to use. And at the same time, if your job is to sell hardware, basically when we did the pricing, where Clever Cloud has a function as a service based on Wasm, and when we tried to do the pricing of this thing, the pricing unit was so small that it was absolutely not profitable for us to do it. And it's great because on the one hand, it means that it's going to be cheaper for you to run stuff in the cloud because it's going to allow us to increase the density of workload running on one machine dramatically. It's great because it's great for basically it's great for the planet, it's great for your money, but when your job is to sell as much hardware as possible, and I call them retail cloud, a retail cloud is just, I'm going to buy some square meters and hardware and I'm going to sell it as much as possible. Then it becomes a problem because it's too cheap. Is that a problem for everyone? Not really, no.
Thank you.
Thank you. I think there was one question here, and then we'll leave you.
Thinking, is there like a good resource to go to see what sort of like the idioms and like the standard ways of doing things? Like, is there a standard set of providers and stuff?
Best resources, WasmCloud Slack, WasmCloud community call every Wednesday. They all recorded. They have you can search for all those WasmCloud call, and basically it's people joining from the community and showing what they're building, and that's pretty great. And the WasmCon YouTube channel, there's a bunch of experience case study. Amex is one of them, and it's a pretty good one. So I invite you to take a look at this. Cheers. Thank you.